We're looking here at Engaged New York Lesson 18, the first problem in the problem set. So number 1, what are we trying to do here? We're trying to prove that CF, line CF, is parallel to line GK. So we have that we know a few things. One is that AL, line AL, is parallel to line BM. We also know that AL here is perpendicular to line CF, and GK is perpendicular to line BM. So we want to use this information in order to fill in. We have statements, and those statements are in order, but we want to also fill in our reasoning so that we make sure that this proof is complete and that everything is working the way it ought to. So let's take a look at our statements. First of all, what we should always do when we're doing a proof is look at the fact that we know that these three things are true. In this case, the AL is parallel to BM, so we have that as a given. We also have that AL is perpendicular to CF, is a given, and that GK is perpendicular to B line BM. Now let's move on and see about some things that we can figure out from the information that we have. One is that the measure of ADC is equal to 90 degrees. Well, how do we know that? We know that because of our given that AL is perpendicular to CF. And the definition of perpendicular lines is that they will have a 90-degree angle at the place that they're perpendicular. So we also have measure of BJH is equal to 90 degrees. BJH is here, and that's 90 degrees. Again, we know that that's the case because we know that the definition of perpendicular lines is that BJH is equal to, or that the perpendicular lines are going to be equal to 90 degrees. Moving on here, we see that BJH is equal to the measure of AHG. Okay, so we have this angle here and this angle here that they are equal to each other. Now, how do we know this? Well, our other piece of information is that AL is parallel to BM. So these are parallel lines. We can actually write the little arrows in here to know that they're parallel lines. And we can know that we have corresponding angles here. And if we have corresponding angles of the transversal, then these two angles are equal to each other. So we put here this reasoning that if two parallel lines are cut by a transversal, then the corresponding angles are equal in measure. Now, here it says that the measure of angle ADC is equal to the measure of AHG. So here we're looking at the fact that we know that ADC up here is 90 degrees. We also know that the measure of AHG is also going to be 90 degrees. How do we know that? Well, it's equal to AHG is equal to BJH, and BJH is equal to 90 degrees. So basically 90 degrees is equal to 90 degrees, and that is what we're calling the substitution property of equality. Okay, we're substituting those two equaled, that we have this equal, and now we're making sure that we have that ADC is equal to BJH. So we have that substitution property of equality. And then our last but not least, we're trying to make sure that CF is parallel to GK. And now that we know that ADC is equal in measure to AHG, that those now are also corresponding angles, and they're corresponding where AL is the transversal and CF and GK are the parallel lines. So it's basically the reversal, the inverse of the corresponding angle theorem that we know. So if two lines are cut by a transversal such that the corresponding angles are, and this should be equal in measure, then the lines are parallel. So CF is parallel to GK.